All right, so hello, my dearest students. I'm trying to record these video lectures so that you can preview or understand the material much better. So, welcome to my channel, and this is my first tutorial. We're going to review today the 7th grades, second quarter, according to Kazakhstan educational program, and make some introduction to the third quarter of physics classes, guys. Hey, the best subject in the world. So let us just revise what we have learned during the class. So during the second quarter, we've learned that physics is the language of nature. It describes how nature works. And scientific method is a method we use to describe some phenomenon in the most accurate way. So first, we develop a hypothesis, which is our guess. Then we need to experiment our hypothesis, and if hypothesis is correct, we develop a theory. International system of units is used in science and is understood by all nations and countries. We need it to avoid misunderstanding. For example, we all measure mass in kilograms, or velocity in meters per second, or distance in meters, or time in second. I should have shown them first. And there are many more examples like that. For example, force is something that we will learn later, is measured in newtons. Let me show it to you. Newtons. Okay, next time I'll keep my internet turned off at the very beginning. So we need vectors and scalars because we use similar operations with each of them. Vectors have magnitude and direction. Scalars have only magnitude. For example, kilogram would be scalar, okay? I mean, 7 kilograms. It is mass, right? And mass is scalar. 7 meters per second. What is this? This can be velocity or speed, right? But in this case, we haven't specified direction, so it will be just speed. And it will be scalar. However, if we say 7 meters per second to the north, then it will become what? These two combined will make velocity. Velocity has magnitude and direction. Thus, we can say that velocity is vector. Okay? There are many more examples for vectors and scalars. So vectors can be position. I thought I've turned it off. Position, velocity, acceleration, force, and others. Scalars are volume, density, mass, what else? Length, or distance. Another good example for vectors are displacement. Okay, I hope that you remember everything from the second quarter. Next thing to learn is motion is something relative. That is why we need frames of references. For example, person in the car thinks that the car is not moving, but the person outside can clearly see the motion. For example, if there is a car and there is a person inside, and if the car is moving forward with some velocity, the outside observer would think he is moving. It looks like mooring. It is V, guys. But the person inside the car can see a car surrounding itself. You can only see the road, but inside of the car, like, you know, there's steering wheel, there is like gear shift, there is like player, and he can see all of these things. All of it is not moving. You know? You get it? So this person thinks that all of this is not moving, but he knows that he is moving. What this person sees is that the road is approaching it. You know, it looks like the road is moving to him. So this is what? Relativity. Относительность. Okay. Distance is scalar. It measures how much we traveled. Displacement is vector. Shows how our position has changed. Distance equals speed times time, and displacement equals velocity times time. Speed shows how fast it is, and velocity shows how fast and in what direction. You see here, speed shows just the magnitude. It shows how fast. Yes, 7 meters per second. But vectors show, like velocity shows us how much and in what direction. You see? It shows both the magnitude and direction. Acceleration shows how velocity changes with time. Acceleration equals velocity divided by time. Density equals mass over volume, and it is measured in kilograms per meter cube or grams per centimeter cube. By the way, guys, I forgot to mention what acceleration is measured in. It is measured in meters per second squared. Velocity, distance, and displacement are measured in meters. Displacement is measured in meters. However, it also shows direction. Velocity and speed are measured in meters per second. Velocity is meter per second plus direction. Okay, so we know what density is. Density is mass over volume. It shows how much stuff is inside some volume. For example, density of iron, like I'm just giving an example, is 7,800, and density of water is like 1,000. So if they have same volume, like if we put them equal amount of iron and equal amount of water, then if they are both 1 liter, then water will have mass. Like if we put them both on some scale, my drawing skills are awful, guys, I'm very sorry. So, oh, here is a mistake. It's supposed to be 7,800. Oh my god. What's going on? What's going on? What's going on? Gosh, there's some bug. I guess I'll just maybe change the keyboard and it will work properly. Equals 7,800 times 1 liter. Okay, nice. So this equals 7,800. Oh my god. 7,800 kilograms. And this one is 1,000 kilograms. What? Am I correct, guys? No, because it was 7,800 kilograms per meter cube, and meter cube divided by liter will be 1 over 1,000, so it was supposed to be grams. Okay, I'll explain it right here. What do I mean? So you see, 1 liter equals 1 decimeter cube. Okay, which means 1,000 1,000ths of meter cube. Okay, because decimeter equals meter divided by 10. So decimeter cube equals meter cube divided by 1,000. Okay, we need to take both into cubes. Alright. So, yes, 7,800 grams, 1,000 grams. So, what does it mean? What does it mean? This comes here, this goes here. So, this one will show us 7.8 kilograms. And this one will show us 1 kilogram. You see? But their volumes are same. Okay? Anyway, so we can use these triangles. So if we cover up mass, then mass equals density multiplied by volume. Or if we, for example, if we cover up density, then density equals mass over volume. If we cover up volume, then volume equals mass over density. In similar fashion, you cover any part of the triangle and you can find out what that value is equal to. For example, distance equals velocity multiplied by time. Velocity equals distance divided by time. Time equals distance divided by velocity. And so on and so forth. Velocity equals acceleration multiplied by time. And acceleration equals velocity divided by time. So